In this video, we're going to be looking at the LZX Industries Sensory Translator. The Sensory Translator is a 5-channel audio envelope follower. The Sensory Translator has 2 audio sources. It has an external input that's switchable between line level and plus/minus 5 volt levels that are more common on modular synthesizers. It also has a built-in microphone. This is switchable between plus 20 dB of gain, 0, and negative 20 dB of gain. It also has an output so you can patch it into other parts of your system. And each of these audio sources has its own dedicated gain knob and a global bass and treble EQ. The audio source is split into 5 different frequency bands. These can be accessed directly from the jacks on the front panel. They're also passed into an envelope follower, which can be set to either amplitude envelope or impulse envelope. We'll discuss what that means later. There's also a speed control that dictates the speed of the envelope, whether it goes very fast, medium speed, or very slow. Each of those outputs is available at the bottom of the module. This gives you a lot of flexibility in controlling your patches with audio sources. So let's jump right in and look at our first example. For this first patch, I'm going to start by building a fairly simple shape. So I'm going to take the H and V ramps from my diver. You could also use ramps from Cortex for this. And I'm going to put them into a classic Navigator shape changer combo. I'm going to take the gradient output from my shape changer, put that into a fortress, just for a quick colorizing effect. And I'll take my fortress outputs directly into my visual cortex. So my diver ramps are being modulated by the Navigator. This is just a very basic circle shape ramp. I have mirror X and Y turned on the diver. You could get basically the same exact effect by coming out of the H plus V ramp on the visual cortex. And now the shape changer allows me to modify this shape. Now I'm going to use the sensory translator to take the sound of my voice and use that to modulate this shape on the shape changer. So I'm going to start with a 640 Hz band. The LEDs will give you a good idea of which bands are particularly active when you're speaking. So I'll take the C output, and I'm going to go into the ratio voltage control on my shape changer. Right now I have my envelope set to slow. I'm going to move that up a little bit to fast so it's a little more responsive. And immediately you can see the effect. I have my microphone set to plus 20 decibels of gain. I can adjust the gain knob. If I turn it all the way down, I should see no effect. If I turn it all the way up, I'll start to see a pretty dramatic effect. Let me adjust the ratio voltage control and the controller itself. There we go. So I have this on a very fast setting, and I'm going to keep adjusting my gain until I'm getting a relatively dynamic effect. So next, I'm going to take a different band, in this case 2560 Hz. I'm going to make sure that's set to fast, and I'm going to plug that into the skew voltage control. So now, as I adjust these settings on my skew, I should begin to get a secondary effect. There we go. It's pretty important with this module to spend some time making sure that you're getting the settings to where you like them. It can be really tricky, especially if your voice is not super consistent. So now that we have a basic patch set up, we can play with the different envelope follower ranges. So if I switch these both to slow, you can see we get a very slow fall off from the effect. This is going to make it less dynamic. The medium range is going to do a similar thing. So you can see how the modulation kind of trails off. And of course, fast is going to give you the fastest and most erratic results. There's also a switch on each channel between AMP and IMP. AMP stands for amplitude envelope. IMP stands for impulse envelope. The amplitude envelope is going to give you a more smooth envelope on the output, whereas the impulse envelope is going to give you more of a spike. This is useful if you want to use these outputs to trigger something, such as an envelope, or the trigger inputs on the memory palace and the diver. So we'll keep that set to amplitude for now. You could also start to take your additional outputs, plug them into different parts of your patch for a much more dynamic effect. And of course, you could have some set to slow or medium and some set to faster. Let's take this E output and go into a phase input on diver. Let's go to the horizontal phase. There we go. And you can really just start to have a lot of fun. You can also take the direct audio outputs. So in this case, I'm going to take the 640 Hz output. This is before the signal hits the envelope follower. It's going to look pretty noisy because it's just an unmodulated audio signal. But in some cases, such as when modulating diver, this is going to give you a really nice effect. So I've just plugged that into the wave voltage control input, and I can adjust how much or how little of that I want. Now notice there'll always be some residual background noise. In this case, I'm picking up the sound of the case itself. If I turn the gain down, I can find the sweet spot where that starts to not become a factor. Or, if I want to go the other route, I can turn the fan on my vessel to generate a little bit more noise. And then I can use the high gain microphone input from the sensory translator as something of a noise source. And of course, you can play with all sorts of environmental sounds. You can even just tap on your modular. So that should give you a good basic idea of how to get started using the modulation outputs on the sensory translator. In the next example, we're going to look at using an audio source from a synthesizer. So in this next patch, we're going to look at an example of how you can use all 5 outputs of Sensory Translator to create different layers of control within a patch. Memory Palace has a huge array of voltage control inputs, which all work great with Sensory Translator. So for the sake of simplicity, we're going to primarily use the Memory Palace for this example. So I'm going to take the RGB outputs from Memory Palace to get started, plug them into my visual cortex. I've got the inputs on my Memory Palace in split mode, which means it will take color information from an incoming RGB signal and the alpha information from a built-in still. So for that color information, I'm going to plug in a fortress. This is just in a basic pattern mode. And as you can see, it's just creating a very fortressy type of shape. You can see that. And the key in this case is being generated by a built-in square ramp that comes shipped from the factory in the Memory Palace. In the audio input of the sensory translator, I have a signal coming from an external synthesizer. I do not want to use the microphone in this case, so I have the gain set down to -20 dB and the knob turned all the way down. I could, if I wanted to, mix in some of the microphone as well. So I have a synthesizer hooked up to a sequencer. I'll start the sequence. You'll notice the lights on sensory translator. I've intentionally set a sequence that goes from very low frequencies to very high frequencies. The synthesizer is also using a sine wave, so we get a very pure representation of the different frequency bands. I'm doing this primarily for demonstration purposes. It's probably pretty rare that you'll encounter musical material that has this kind of separation between the bands. So let's begin with some of our lower frequencies. So I'm going to take the A output, and I'm going to try plugging that into the zoom input on my Memory Palace. As I bring up the voltage control, you should start to see that having some effect. Now I have my zoom and aspect controls set to control width and height. So as you can see, whenever the red light goes off on the sensory translator, we're getting that width to stretch out. I could switch to a faster envelope or a medium. Personally, I tend to like slower envelope speeds for lower frequencies. I could also switch this to impulse mode and switch it up to the fast setting. And then you see we just get these little triggers, which in this case is not what I want, so I'll leave it on amplitude. Next, I'll take a different output to plug into the aspect voltage control. I'm going to go with D. And again, this one is set to slow. Sorry, that one's set to the medium speed, but I could also set to slow. And let's start to bring this up. So now you see it stretching in the other direction when the D band is triggered. So maybe I'll make this one a little bit faster. For the B band, I'm going to put that into my center control. So this will start to adjust the basic shape of that rectangle. I'm going to turn down the zoom and aspect for now so you can just see what each band is doing. So B, again, is set to amplitude and set to fast. So let's turn that up. So now you can see whenever the B light is on, we're getting a pretty dynamic modulation of that key. And I could adjust the width controls, get some different effects, adjust the softness. And then let's plug the C into a color control. So again, I'll turn that back down. Let's go into the hue control. Let's see what that looks like. So now you can see it giving us some color modulations when that C envelope is triggered. And again, I can switch to different speeds. I could even switch it to impulse just to get some very, very quick flashes of color change. That actually might be better suited in the contrast input. Just get these very quick bursts of brightness. But for now, I'll set it back to amplitude, set it in the middle, and we'll go back into our hue control. So finally, for the E output, I'm going to go into the trigger input on my memory palace. Now the trigger input can be assigned by using a menu. I won't zoom into it right now. You could see some of the ins and outs of Memory Palace in another video. But if I go over to the trigger menu, I can set this trigger input to trigger any of these buttons. So right now I have the trigger input set to turn on tile, reflect, X mirror, and Y mirror. So I'm going to set this down to impulse mode. Keep it set up at fast. And plug that into the trigger input. So as you can see, it is having an effect, but it happens very, very quickly. This is because this impulse output is so fast that it's literally only triggering for a frame. This very, very quick triggering may be what you want. But because the trigger input in the Memory Palace is set to trigger whenever the signal gets above a certain voltage, the amplitude mode is going to work here for us as well. So if I switch this back to amplitude envelope, if I adjust from fast to medium to slow, I can control how long that gate is on for. So on slow, it's going to give me a really long period for that mirroring. I think I'll keep this at fast. So now we can start to introduce our other modulation sources and dial them in until we get the kind of reaction that we like. And I can play with some of my different fast to slow ranges. And then one thing I really like about Sensory Translator is I can adjust the global gain. And so this is going to increase or decrease the effect of all of my modulations. This gives you a very cool level of control in a live performance. So you can go from very, very subtle to very, very extreme by just controlling this one knob. And of course, you also have the bass and treble controls, which you can do a similar effect with. So here I can choose just to accentuate these lower portions, which you'll see most dramatically in that horizontal stretch. Or I could pull that out entirely and start to accentuate just my vertical modulations. So it gives you a little level of interaction with your performance controls. Okay, let's bring these all down again, because there's one last thing I want to show you. I'm going to pull that trigger out just so we're starting pretty basic. In addition to controlling this way, I'm going to just go into the aspect control here. You can also combine Sensory Translator with other modulators. So I'm going to take the D output, go into the through input on a passage, take that output back into my aspect control. Let's turn that up just so we can start to see what that's doing. All right, so now we're back to seeing the same old thing. If I put an LFO into the second channel of my passage, now I can start to sum these two modulation sources together. So I could do a really, really slow. Now we get the LFO having some effect. If I do it really fast, you'll probably see it a little bit better. So now we have a combination of our audio input and an LFO affecting that aspect ratio. Alternately, you could use the crossfader as well. So I'll take the D output from crossfader, and I'll put LFO1 into my cross VC, and I'll take this output into my D. So now, this audio modulation is only going to appear in the aspect voltage control when the LFO is high. This just gives you another way to make your patches a little bit more dynamic. So let's pull everything back up again. And throw our trigger back in. So there you have another very dynamic way to drive an entire patch with an audio input from the Sensory Translator. In the next patch, we're going to look at some ways you can use Sensory Translator with no audio input at all. In this last patch, we're going to look at an uncommon but specific use of Sensory Translator. One question that always comes up with new LZX modules is, can I run external video through it? The answer is almost always yes. Whether or not the results are desirable is up to you and your tastes. But it can be a very unique effect, especially if you're into glitchier aesthetics. So to begin, I have an external video playing off an Andor 1 media player. I'll just give you a look at that. I know I'm going to want to take this video feed to multiple different sources in my patch. So the first thing I'm going to do is plug it into a multiple using the bridge. This will also give me a built-in gain control, which I really like sometimes for external videos. And now let's take this output directly into the audio input on the Sensory Translator. Again, I have my microphone turned down because I'm not going to want to use it for this case. I'm going to zero out the rest of my controls. And let's begin by just looking at the fastest output on the Sensory Translator. The fastest meaning highest frequency, in this case 10,240 Hz. So as I start adjusting my gain, you'll start to see the LEDs light up. Now if I plug into the envelope outputs, I'm really not going to see much. Most of these channels will just be straight up white. Now this is because it's triggering the envelope followers way too fast for any perceivable result. If you set to IMP, you might see something in certain ranges. A little slight flicker perhaps. But really what we're going to want to use for this patch is the direct band outputs. So if I go from the highest one, we'll start to actually see something. Now this highest frequency band just starts to sneak into the vertical range. If this were a video oscillator at this frequency, you would see 1 or 2 vertical bars. As we move down the frequency ranges, you'll start to see more horizontal material. So now you can see some horizontal bars, just one or two horizontal bars, and just one. So that should give you some idea of what to expect. We could take these horizontal bars out of Sensory Translator, plug them into the wave input on Diver, and then use it to generate vertical bars. If you're familiar with Diver, this is one very common use case for the module. So you can see vertical bars. If I switch back to the basic output, corresponding horizontal bars, and back to our vertical bars. And of course, you can also view the H plus V outputs. And if I adjust the gain over here, start to get some different effects, some different movement. So that's a fun side note, but it's not what we're going to be focused on today. So you'll notice as I modulate the gain, I again get some modulation of the signal. And if I adjust the treble control, I'm going to get almost a keyed effect on those edges. I can also adjust the gain on the bridge. I'll just keep that zeroed out for now. And it would be nice to be able to modulate this gain for a little bit more of a dynamic effect. So to do that, I'm going to take my video signal and plug it into a crossfader on my pendulum. I'm going to take LFO1 into the cross voltage control, take the D output back into audio. So now if I turn this all the way up, you can see what that's doing. So this is going to give me a little bit of modulation here. And then to give this a little bit more excitement, I'm going to go into the H input on my navigator, take the H output, and this is going to give me a little bit more dynamic control. Now Navigator in this case is not working the way you would think with typical rotation X and Y controls, but it is allowing me to take that gradient that's being generated by the Sensory Translator and modulate it in some interesting ways. You could use almost any gradient processing module, such as staircase, shape changer, doorway, etc. for this purpose. I still have these other 4 audio outputs to work with, so I'm going to take a different one, in this case 640 Hz, and I'll plug that into the vertical input. And now I need some way to combine these two signals. So I'm going to use Fortress in this case as my colorizer. You could also use color chords, marble index, mapper, anything to get a color signal. I'm going to take the RGB outputs, and we've been using this a lot in this video, so I'm going to swap the RGBs just to get a little bit more of a variable color, and turn all my ADC inputs down and make sure all my switches are down on the program and the palette. So now I can take my H and V outputs from the navigator and plug these into ADC1 and ADC2 on the Fortress. And now as I adjust the controls on Navigator, I'm going to get a pretty dynamic color mix. And while this pattern is all being generated by the external video, we're kind of losing sight of the original video itself. This may be okay for your purposes, but if you want to introduce it back, I could take another output from the multiple. I'm going to put that in the ADC3 input and turn that up. So by mixing the original video back in, we start to see the kind of effect it's having and what the Sensory Translator is actually doing in the patch. And from here we can adjust different controls, switch through different palette modes, and start to play around with our patch. So again, while this isn't something you would necessarily want to use all the time, it is a pretty unique and interesting way to process an external video in a very glitchy way. And we can adjust the crossfading of that external gain signal. You could also use passage for this, which would give you a very different effect. Again, we can change the gain of our video. This is going to upset the ADC3, so we'll want to bring that back down. And adjust the overall bass and treble controls. And the overall gain. And play with our navigator to change how that gradient's affecting the colorizer. And finally, we'll get very different results by switching through the different frequency bands. In my opinion, the 2 highest bands tend to work the best for this effect. but depending on what you're going for, all of them can be great options. We could also get the diver involved again. Go back to that H output, take one of these slower bands, flip it into vertical bars, just to get something a little bit different. So you can see those vertical bars starting to be integrated. We could set some scrolling on here and get a really wild, pretty glitchy effect. So hopefully this gives you some idea of how to get started with your sensory translator. While its most powerful use is as a 5-dimensional audio-to-envelope generator, as with all LZX modules, it never hurts to experiment plugging some unusual sources into the different inputs. We hope you enjoyed this video, and as always, please leave any questions or ideas for future videos in the comments below. Thanks for watching.